Welcome back to our RPG tutorial series. In this episode, we will improve the player movement by adding animations in all 4 directions, so the character already starts to feel much more alive. After that, we will take the next big step and connect 2 different maps with scene transitions. And to make that work properly, I will also introduce global scripts and show you why they are so useful for a growing project like this. So let's get started. Let's take a quick look at the player's movement so far. As you can see, our player is already moving, but right now we only have a single animation. So let's fix that. We're going to create a separate animation for each movement direction. The good news is we already imported all the required sprites in the previous tutorial, so we can jump straight into the script. First, we create the new function to handle our animations. When calling this function, we'll pass in a value. This value will be stored in a variable called movement. That way we can control the function based on whether the player is moving or not. For now, we'll just write pass to avoid any errors. Now, we call this function inside our movement logic, so every time the player changes direction, this function gets called. And we pass a value of 1 into the function. You can simply copy this line here. And if the player is not moving, we pass in a value of 0. This allows us to clearly distinguish between moving and standing still. Next, we define a variable for direction. This will be a string. And just like before, we update it every time the player changes direction. So if we move right, it becomes right, left becomes left, and so on. This variable gives us full control over determining the player's direction. So based on its value, we always know which way the player is moving. Now, inside our animation function, we create some local variables. These are only used within the function itself. For example, we define a variable that stores the path to our animated sprite 2D. That way, we don't have to drag it in every time. We can just use this local reference. We can also just reuse an existing variable and shorten it for this function. These are simply 2 examples of how local variables can be used. It's not strictly necessary here. This is just to give you a practical idea of how they work. Alright, now let's build the logic. First we check the direction. Then we check if the player is moving. Based on that, we decide which animation to play. For example, if we're moving to the side, we play walk side. If we're not moving, we switch to idle side. Since we only have 2 states here, we don't need to explicitly check if movement is 0. An else statement is completely enough. And that's already most of it. Now we just repeat this logic for all directions. One important detail, our side animations are facing right. So instead of creating separate animations for left, we can simply flip the sprite. We use flip_h for that. If we move left, set it to true. If we move right, set it to false. So we reuse the same animation, just mirrored. Now we do the same for up and down. Here we use walk front and idle front for moving down, and walk back and idle back for moving up. We can leave flip H in both cases and just set it to false. It doesn't really matter here. And that's it. Let's test it. And there we go, our character now turns in all 4 directions. He walks when he should and stands still when he should. Now I'm going to slightly reduce the movement speed so it feels a bit better. And I'll also adjust the animation speed. For example, we can set it to 6 frames per second. Since each animation has 6 frames, this works quite nicely. It already feels much better. The movement is smoother and the animation fits the pace. Of course, you can tweak these values however you like. Alright, our player can now move, but there's nowhere to go yet. So let's fix that by adding a second map. We'll create a new scene and call it Camp. And just like before, we'll build a small map. We can reuse our existing tile sets, of course. I'm going to speed this part up. You already know the process, and if you're not sure anymore, just jump back to tutorial 1. Make sure your map connects logically. For example, we'll use the lower exit from our previous map. So here we create a path that lines up with it. That way, when we switch scenes, it feels like the world continues seamlessly. We'll also reuse the same layers: ground, cliffs, Y-sort, and our additional layer for visuals. Alright, something like this could be our camp. Feel free to get creative here and design your own version. Now, when the player enters this area, they should appear right here at the entrance. So we instance the player into the scene and position them accordingly. That way, this is where the scene starts. Next, we need to create an exit. So let's add a script to our camp scene. Quick note, when switching between scenes, the script doesn't change automatically. You need to select it manually here. Now let's create a new script for the camp and save it in the correct folder. Before we start coding, we need something important, a signal. We need a way to detect when the player leaves the map. For that, we use an Area 2D. This node can emit signals when something enters its area, but Area 2D doesn't have a shape by default. So we need a collision shape 2D to define its area. Think of it like this. Area 2D sends the signal, collision shape 2D defines the shape. We'll use a simple rectangle and place it at the exit. When the player enters this area, we switch to the camp scene. Now, we need to connect the signal to our script. Since we're currently in the world scene, we connect it there. We use the body entered signal. This gets triggered when a body, like our player, enters the area. Before connecting it, let's give this node a proper name. That way, the generated function name will be more meaningful. Now we connect the signal, and we get something like on camp exit, body entered. Inside this function, we check which body entered the area. We only want the player to trigger this. There are several ways we could handle this check, but for now, we'll stick with a simple approach. So we check if the body has a specific method, for example, a function called player. Our player doesn't have that yet, so let's quickly add it. Go to the player script and create a simple empty function called player. It doesn't need to do anything. just acts as an identifier. Now, when the player enters the area, we can detect it correctly, and then we simply switch the scene using get tree, change scene to file, and select our camp scene. Alright, let's test it. Perfect. As soon as we enter the area, we switch to the camp, and as you can see, all collisions are already working, so the map is fully functional. Now we just need one more thing, an exit from the camp back to the world. And for that, we do exactly the same thing we did in the world scene. We add an area 2D and a collision shape 2D. Place the rectangle in the correct spot. Then go into the camp script, connect the signal, and use the exact same logic as before. The only difference is that this time, change scene to file will take us back to the world scene. Get_tree gives us access to the current scene tree. Through it, we can control things like switching scenes, reloading the game, or accessing other nodes. And now we can walk into the camp and also back out again. But this introduces a new problem. When we return to the world scene, the player appears at the default starting position. So our next task is to create a proper spawn point here at the entrance. Now, you might notice that we're getting a couple of warnings here. Godot is telling us that this function could potentially cause issues. We could fix this using call deferred, but instead we're going to restructure our system a bit, because we also want better control over player positioning. So for that, we're going to create a new script. And this time it's not attached to any node. We just create it directly inside our scripts folder. Let's call it global. For us, this will act as our global script. The name itself doesn't really matter, but it must be different from the name we assign globally. Now we go into the project settings and register this script as a global. This means we can access it from any other script, including its variables and functions, without needing a reference. We add it here and give it a name. For example, global. This name is important because this is what we'll use in code to access the script. And again, the script name and this global name must not be identical. Now, inside this global script, we define variables that both camp and world can access. This will make scene transitions much easier to manage. So we add a variable for the current scene, a variable to check if we're currently switching scenes, another one to detect whether it's the first time starting the game or a transition. And finally, we define variables for positions, so we store X and Y values for the player's spawn position in the world and also for the exit position. This gives us a central place to manage all scene transitions and player positioning, and that will make everything a lot cleaner going forward. Now, we still need to define the exact values for these positions, and we can simply take them directly from the player. So first, place your player in the scene and check the transform values. This shows you the position in the global coordinate system. We'll use this as our starting position and store it in our script. move the player to the level exit, and again, copy those position values. These will become our exit position, which is where the player will appear after switching scenes. Now, we can also define functions inside our global script. These can be accessed from any other script. To demonstrate this, we'll create a function called finish_change scenes. This function will be called from our other scenes. First, we check if a scene transition is currently happening, then we reset that flag back to false. Next, we check which scene we are currently in, and based on that, we decide where to go next. So, if we're in world, we switch to camp. Otherwise, we switch back to world. Quick reminder, for comparisons we use double equals. A single equal sign would overwrite the variable. Now, we can call this function from our world scene. In addition to that, we'll also use the ready function, the process function, and create a custom function called change scene. This will give us a clean and flexible system to manage scene transitions and player positioning. So, inside the ready function, we first need to check whether the game is being started for the very first time. Based on that, we define the player's position on the map. If it's the first start, we use the position we saved in our global script, and we do that for both the X position and the Y position. Let's give this node a proper name so we can identify it more easily reading the script. That gives us our default starting point. If it is not the first load, then we use the exit position instead. So this is how the game knows where the player should appear. Inside process, we simply keep calling our change scene function. This function will handle the actual scene transition. Now, when the player leaves the scene, our signal sets the global variable transition scene to true, so the scene change only happens inside this new function. Since this function runs continuously, we use this variable to make sure it only executes once. But first, we still check which scene we are currently in, just to be safe. Then we trigger the scene switch. After that, we set first load to false. That way, the game knows this is no longer a brand new start, but a transition from another scene. And to properly finish the whole process without getting those warnings anymore, we now use our global function finish_change scene. And I can already see a typo here. That's exactly why I often copy and paste things. These little spelling mistakes love to sneak in. And this is basically how you access variables and functions from a global script. We'll be using this a lot more later on. This is really just the introduction. Now we can take the same logic and put it into the camp scene as well. Of course, we need to adjust the variables here, so the transition works in the other direction too. Inside the signal, we use our global variable again. This ensures that the scene transition is handled only inside our dedicated function. We just trigger it here. And also update the variables accordingly. Call change scene inside process, and I think that should be it. Well, almost. Looks like another typo slipped in. Let's see. Yep, the problem is inside the change scene function. A tiny spelling mistake, and once again it causes trouble. Most likely I just didn't copy the variable correctly. So, quick fix in both scripts. And now it works. We enter the camp, we go back out again, and we appear exactly where we wanted, right at the exit. And if we restart the game, we spawn at the original starting position. And just like that, our two scenes are now fully connected. I'll put a link up here in the top right to my second playlist. If you want to build larger worlds or connect multiple scenes more efficiently, definitely check that out. You'll find more advanced tutorials there focused exactly on that, building bigger, cleaner, more polished worlds, and I'll keep expanding that playlist over time with more detailed topics like combat systems and other advanced mechanics. So make sure to take a look. Now, let's move on to our combat system. For that, we first need a new animation for our player. We'll create an attack side animation and assign the correct sprites. And that's what it will look like when the player attacks. But of course, we also need something to attack. So let's add an enemy. We'll create a new scene, again using a character body 2D, with a collision shape 2D and an animated sprite 2D. For our enemy, we'll use this small slime. It's included in the asset pack by Game Endeavor, and it's perfect for building basic combat systems. First, we create a simple idle front animation, so we can place the enemy into the world. That's how it will look in game. We also add a collision shape, of course, so it interacts properly with both the environment and the player. Then we save the scene as usual. Now we can instance the enemy into our world, just like we did with the player. Let's name it enemy and place it somewhere suitable. We already have a player script, but not yet one for the enemy. So let's create one. For now, we'll keep it simple. Inside the ready function, we just play the idle front animation. Now, when we run the scene, our enemy is already there. Before we wrap up, there's one important setting I want to show you. Go to the project settings. Here we can define the main scene. the scene the game starts from. We simply select it here. In our case, that's the world scene, since everything is built around it. Now, no matter which scene or script you currently have open, you can always start the game from the correct entry point with a single click. Alright, quick note before we move on. I just realized something important. We haven't fully set up our camera for the camp map yet. As you can see, the camera doesn't reach the edges of the map, neither to the right nor to the bottom. And that's because our current camera settings don't match the size of this second map. Now, one option would be to simply make all your maps the same size. But if you want different map sizes, like I do, there's a better approach. Just use two separate cameras. So let's rename this one to Camera World and create a second camera for the camp. Before we continue, let's quickly enable Y sorting in the camp. Just activate it on the node 2D and on the Y sort layer. Since we're using the same tile set as before, everything should already work correctly, including all the collision and sorting behavior. Now, to set up the camera limits for the camp, we again need to know the size of the map. So we place a marker in the bottom right corner and read out the X and Y values. Now we can apply those values to our camp camera limits. To save time, instead of configuring everything from scratch, we can simply duplicate our existing camera. That way, all previous settings are already in place. We only need to adjust right and bottom limits. Now comes the important part. We need to control which camera is active, so inside the player script we create a new function for camera handling, and here we use our global variables again. We simply check which scene we're currently in, world or camp. Based on that, we activate the correct camera and disable the other one. We do this in both cases to make sure only one camera is active at a time. Don't forget to call this function inside physics process. Now let's test it. In the world scene, everything works exactly as before. And in the camp, we now see the full map with correct Y sorting all the way to the edges. So, quick takeaway. If you're working with different map sizes, it's best to use one camera per map. And that's it for this episode. We now have improved player movement, animations in 4 directions, and a basic scene transition system in place. In the next episode, we'll continue building on this foundation and expand our project even further. If you enjoyed this video, feel free to like and subscribe. It really helps support the series. Thanks for watching, and as always, have fun coding.